Number 17, I'm going to tell you what to pick for your u, but then I'm going to do 19 just because it's a harder version of almost the same thing. What do you guess you should pick for 17? Okay, you should pick sine, but you should not pick the squared. Okay, the reason why is because if you pick sine squared, then your du is going to be too complicated and stuff doesn't cross out right. Okay, so we're going to do 19. Now, given what we just picked on 17, what do you guess you should pick on 19? Okay, cotan, very good. So u equals cotan x. Now, should I pick the squared? No. Okay, ready? I'm going to put my rules sheet up here. I want to know what the derivative of cotan is. I'm assuming you probably don't have that memorized. Okay, here it is. What's the derivative of cotan? Negative cosecant squared. Okay, it's rule number 19. So, du dx is negative cosecant squared x. Then I move my dx up, and I move my negative cosecant squared down. So I have this now. dx equals du over negative cosecant squared x. Good so far? Okay, let's substitute some stuff out. So my original integral is going to keep the cosecant squared on top. And then my cotan is now going to be a u squared. So far, so good? Okay, then what is my dx now? A du over negative cosecant squared x. Okay, what's going to cross out? Cosecant squareds. Will anything be left over?
Negative.
That negative is going to be left over. And then if my u is squared on the bottom, like this. Okay, I forgot to make sure you keep that negative there in the front. Okay, is that going to be an ln as my solution? No, it's a rewrite. How do I rewrite it? U to the minus 2. And then from there, you just do your power rule on it, blah, blah, blah. Okay, so I'll add 1. What is negative 2 if I add 1 to it? U to the negative 1. And then if I divide by negative 1, and there was already a negative 1 in the front, now it's a positive 1. Okay, and then plus c. Okay, then for my final answer, I would say, okay, well, this is the same as 1 over u plus c. 1 over u plus c, because it's a u to the minus 1, and then I'll plug in my cotan. Now, quick question. 1 over cotan x plus c. On the AP test, they wouldn't put this as an answer choice. Okay, the reason why is because 1 over cotan is the same as what? Tangent. Very good. Okay. So that is the same as tan x plus c. Okay. But if you got it to here, then I would, if it was like free response or something, that would have been totally fine. Just if it was multiple choice, they would probably want you to know 1 over cotan is the same as normal tangent. Okay? So the goal for today is to add endpoints to the u sub that you can do. So if you look at your homework for today, instead of it just being, remember that these are called indefinite integrals because they don't have endpoints. Okay, your new integrals are definite integrals, meaning that they have endpoints. Okay? So we are going to take some notes. Are you ready? Yes, we're ready. Okay, number 1. So this is u substitution for definite integrals. And remember that a definite integral means an integral with endpoints. Okay? An integral with endpoints. So let me just very first remind you that in order to find the integral a to b of f of x dx, okay, you're going to do capital F of b minus capital F of a. Okay, remember that that's how you evaluate an integral with endpoints. Now, there are two ways for you to do this. I'm going to show you both. Okay, the first one is a little bit longer, but every year there's like 10 kids that like this way better, so that's why I'm going to show you both. Okay, so if you are doing the integral, ready? This is number 1. We'll write out steps for the shortcut. Okay, you would do the integral from 0 to 1, 6x x squared plus 1 cubed dx. Okay, the beginning part is the same. What would I pick as my u?
Oh, x squared plus 1.
Okay, x squared plus 1. What is du dx then?
2x.
2x. Okay, then I move my dx up. I move my 2x down. So dx is now du over 2x. So far, so good? Okay, we're going to rewrite our integral. 6x in the front. This is now a u to the 3. And then my dx is now a du over 2x. Okay? Divide 6x and 2x. What do we get on the outside? Okay, a 3. And then this is u to the 3 du. Now, for now, I want you to not put any endpoints. This is why. Your integral is in terms of u. These endpoints are for the letter x. So on the AP test, you have to pull, if it's free response, you have to pull those endpoints off. You can't put them back until you have x's again. Okay? So what is the antiderivative of u to the 3? U to the 4th, and then 3/4. Okay, put it in brackets. Now, normally there would be a plus c, but do you remember why we don't include it? Because they just end up crossing out. So I'm going to go ahead and put the plus c just in case you forgot why. Okay, but then we'll see that it crosses out. Okay, then from here you have to switch it back to x's. So then I would rewrite this as 3/4 x squared plus 1 to the 4th. And now I can put my endpoints back. Okay, but the endpoints have to go away because these 0 and 1 are endpoints for x. So once you start putting u's in it, you have to pull them until you're back to x's, okay? Then from here you would plug in 1. Okay, so this would be 3/4. 1 plus 1 in here is 2. What is 2 to the 4th? 2 times 2 times 2 times 2. 16 plus c. Then I'm going to reduce that a little bit more. 16 divided by 4 is a 4 left over. Times 3 is a 12. So that'd be 12 plus c. Next we're going to plug in 0. Okay, so I'd have 0 plus 1 is 1. So I have 3/4 times 1 plus c, which is just going to stay a 3/4 plus c. Then what do we do with those endpoints based on fundamental theorem? Subtract. So it'd be 12 plus c minus 3/4 plus c. And what happens with our c's? They cancel out. So that's why we're not going to continue to put them, in case you forgot. Okay, so then your answer would be 12 minus 3/4. Now, if this was free response, that'd be fine. But if it was multiple choice, you'd want to times your 12 by 4/4 to make it a common denominator. So 4 times 12 on top is now a 48/4 minus 3/4. What's my final answer? 45/4. Good? Okay, that's the long way. Okay, you'll notice that it's very step-by-step, exactly like what we did last time. Okay, I'm going to show you now a shortcut. Okay, we're going to do it with, actually, maybe I have 2 of them worked out the long way, and then I'll show you the shortcut. Okay, but I'll just tell you, buzzkill, it's not really that much shorter. Okay? So, number 2. We'll do one more the long way to make sure you got it. Okay, it's going to be the integral from 0 to 4 of 9 over 3x plus 2 dx. Okay, what do I pick as my u? Okay, 3x plus 2. Now, from now on, what I'm going to start doing is instead of putting du dx, I'm just going to go ahead and write the dx over on this side, just because we know it's going to end up over there anyway. So what's the derivative of 3x plus 2? 3, and then instead of putting my dx here, I'm just going to put it there. Okay? So then if my dx is on that side, then my dx is du over 3. So far, so good? Okay, let's do our rewrite. 9 over u, and then my dx is a du over 3. Your 0 and 4 have to go away, because those are x endpoints. We don't have x's anymore. Okay, 9 divided by 3 gives me a 3 in the front. 1 over u du. What's the antiderivative? 3 ln u. And then, is it okay if we do no plus c? Okay, so 3 ln u. And then when I switch it back to be 3x plus 2, now I can plug back in my 4 and my 0. Okay? Then from here, we're plugging in our 4. 3 times 4 is 12, plus 2 is 14. So that's 3 ln 14. Next, we're plugging in 0. That's going to be 3 ln 0 plus 2 is 2. Okay, then we're going to take those and subtract. So it'll be 3 ln 14 minus 3 ln 2. Then remember that there is a rule that with ln's, when you're subtracting, what can you do with the numbers in the ln's? You remember? You can divide. So instead of ln 14 minus ln 2, it's ln of 14 over 2, which is 7. So it would be 3 ln 14 over 2, which is 3 ln 7. Okay? And then I'll put special log rule. Okay? Questions about that? Okay, a couple of y'all on your test seem confused about when you have to have the bars and when you don't. When you plug in a number and it's not a negative number, that's when the bars go away. So like I don't need to put bars around 14. 14 is already positive. So you wouldn't have to put bars around that. It's not wrong to put it, but it's unnecessary. Okay? Alright, so here is the shortcut. Are we working the exact same two problems? No, these are different. Okay, gonna have to switch papers. Okay, so number 3. This is gonna be, we're gonna do the shortcut now for the rest of the period. Okay, but keep in mind that any of these problems you could have done the long way. Okay, so integral -1 to 0, 12x cubed, x to the 4th plus 1 cubed, squared dx. Okay, here's how the shortcut goes. It starts off the same. You're going to pick your... Now, let me also say one more thing. Even though you could do these the long way, the AP test does test this shortcut method to where you have to know how to do it, because they'll ask you to rewrite integrals using U substitution. So don't think, oh, if I can do it the long way, I'm just going to do that. Okay, you have to learn both for the AP test. So your U is going to be what here? Starts off the same.
X to the 4th plus 1.
Okay, x to the 4th plus 1. What's your du? 4x cubed. And then remember what I said? I'm just going to put the dx on that side, because we know it's going to end up over there anyway. Okay?
great things. The first fact today is February 6, 1820. The Mayflower of Liberia sailed to New York City with 86 flags. Black population, 1,771,656.
Second fact, February 6, 1993, Arthur Ashe died. First African-American tennis player to win at Wimbledon.
Wow.
God.
First African-American to receive a peace statue. Wow, I mean, we've come so far, and I hope this can inspire all of you to keep on pushing forward, because the sky's the limit, guys. Alright, Brandon, have a blessed day, have a rest of the day, and get the diploma thing in.
Good. Wow.
Maybe I should do the announcement.
You would be great on the announcement. I would support that.
I'll get Yossi with me.
Okay, I'm glad that's an important announcement though, okay? It is Black History Month. Okay, so look at your thingy, divide it. What do you get? Just a 3 in the front. U to the 3. Okay, this is where it's different. You're going to bring the endpoints back, but you're going to change them to be U endpoints. Okay, so I'm going to put a star here, and I'm going to put, you are going to change your X endpoints to be U endpoints. And all that you have to do to change them is plug them into what U is. So for example, when X is 0, plug that in. What is 0 plus 1? 1. Okay, now remember I told you it's not that much shorter. It's a little bit shorter, not that much. Okay, now we're plugging in -1. What is -1 to the 4th? 1 plus 1 is 2. And now you can just work the integral out. So antiderivative of U to the 3 is what?
Wait, wouldn't it be U to the 2?
Oh, it was a U to the 2, thank you. Integral of U to the 2 is what?
2U.
What?
Wait.
No, add 1 first. U to the 3. Then I divide this 3 with that 3, and what happens? Cancels out. And now I can just plug in 1 and 2, and I don't ever have to go back to the original X stuff. So then from there I'd plug in 1. What's 1 cubed? 1. What's 2 cubed? 8. What's 1 minus 8? -7. Got it? So the only difference from one method to the other is that if you're doing the long way, you have to go all the way back to X. Versus in the shortcut, you're going to change the endpoints so that you don't have to go back. Now, I'm going to show my work on the first couple of these for the endpoints. Okay, I do not care, and the AP test does not care if you do this. But if you're going to, on Friday, need help on your quiz for this, okay, then I would maybe write it down. So your original endpoints, okay, your B was 0, and your A was -1. But then you're going to plug those into U. So U would be 0 to the 4th plus 1, which is now a 1. And then U would be -1 to the 4th plus 1, which is 2. Okay? So that's to get your new endpoints. Okay? But you do not have to show that step for me. You don't have to show it on the test. Just in case you go back to your notes, I want you to have it. Okay? Alright, that was number 3. Next one. We have 1, 2, 3, 4. 4 left, and then we're going to do some of your homework together. Okay, number 4. We're going to do the integral of 0 to 4, 12 square root 2x plus 1 dx. Okay, and we're doing all of these the shortcut because you have to know how to do the shortcut even if you like the short way better, or the long way better. Okay, what would you pick for your u? Okay, 2x plus 1. What does that make du? 2 dx. Remember, instead of putting the dx on the bottom, I'm just going to put it next to the derivative. Okay, that makes dx du over 2. So far, so good? Okay, we're going to rewrite our integral. 12 square root u, and then instead of my dx, it's a du over 2. Then I combine the 12 divided by 2, and it gives me a what in the front? 6. Integral u. If it's a square root u, I'm going to go ahead and change it to the 1/2. Then at this point, all my x's are gone. I'm going to change my endpoints by plugging them into what my u is. So my original b was a 4. So then what is my u? 2 times 4 plus 1. What's my new upper bound? 9. My original a was a 0. So then my new u endpoint is 2 times 0 plus 1. Well, that's just a 1. And then from there, you never go back to x. You keep it in u's for the rest of the problem. Okay, take the antiderivative. Okay, if that's a 1/2, some of y'all struggled on this problem on your test. 1/2 plus 2/2 makes 3/2. And then when you divide by 3/2, you're multiplying by what in the front? 2/3. Good. Okay, and then I'm going to plug in 9, and then I'm going to plug in 1. Okay, now I'm going to do one more step and kind of clean this up out here. 6 times 2 on top is 12. What's 12 divided by 3? So really that's 4u to the 3/2. Okay? Now, if you do not know how to do these fraction exponents, that is a problem. Okay, we got to know how to do them. That's why we practice them over and over again in the notes. So remember that u to the 3/2 is 9 to the 3 square rooted. Remember, the top number is the power. Okay, so that's why it's to the power of 3. And then this bottom number is the square root. It's the index of the root. So what's the square root of 9? 3, and then what's 3 cubed? So it's 4 times 27. I don't know what that is, so I'm just going to leave it like that. Technically it's 108, but pretend like you didn't know that. Okay, next I'm plugging in 1. So it'd be 4 square root, 1 cubed. But 1 to any power is still a 1, so that's a 4. Then from there, what do I do with these two numbers? Subtract. So that'd be 54 times 2 is 108 minus 4. Okay, but if it was free response, could you leave it like this? Yes. Okay, it doesn't matter. If it's a free response, okay, that's good enough. Doesn't really matter. Okay? Alright, next one. Okay, number 5. Integral from 0 to pi of the sine of x over 2 dx. Oops. Okay, what do you guess you should pick as your u? Okay, how could I rewrite that? 1/2 x, right? Same thing. Okay, so my du is the derivative of a 1/2 x, which is just going to be what? A 1/2 dx, right? Now remember, if it's a fraction on this side, then when I take the divide by 2 to the other side, it'll be a multiply by 2. So I'm going to put a times 2 here, times 2 here. These guys cross out. So my dx is going to be a 2 du. Then I come over to my integral. This is the sine of u du times 2. And then I'm going to take that 2, bring it to the front. Now, quick question here. Are there any x's in my problem at this point? Then I can change my endpoints. That's when you can switch them, is when you don't have two types of letters. Okay, so now that it's all u's, we're going to switch them. Now, look at what your u is. When I plug in pi, what am I going to get now? Pi over 2. When I plug in 0, 0 over 2 is still 0. So it is possible for them to stay the same, but a lot of times they do change. So I have 2 times the integral of sine u du from 0 to pi halves. What's the antiderivative of sine? Okay, it'd be negative 2 cosine u, and then we're plugging in pi halves, then we're plugging in 0. Okay? So then I'd have negative 2 cosine pi halves, and then negative 2 cosine 0. Cosine pi halves, that's your thumb. Cosine's on top, nobody's on top, so it's how many? This is 0, which means the whole thing is 0. Okay, plug in 0. Cosine of 0, that's your pinky. All your fingers are on top. Cosine of 0 is how many? 1. So it's negative 2 times 1, which is negative 2. Okay, is the answer going to come out to be negative 2? No, what will it be? Positive 2. Because you're going to have 0 minus negative 2, yeah? You have to subtract these guys at the end. So that will turn it to be a positive 2. Okay? Alright, 2 more left, and then we will do some of your homework. Okay, number 6, integral. Okay, it's going to be sine cubed x cosine x dx from 0 to pi halves. Okay? Take a guess. What should you pick? Okay, sine x. Very good. Now, do I want to pick the cubed as well?
No.
No, that's too much. So my u is going to be sine x. What is my du dx then? Cosine x, but then I move the dx over. Okay, from there, that means that my dx is going to be du over cosine x. Okay? Then from here, I'm going to rewrite my integral. So I have sine x is my u, so u is cubed. And then my cosine x here stays. My dx is a du over cosine x. What do you notice is going to happen there? These guys are going to what? Cancel out. Very good. Now that my x's are gone, I can change my endpoints. So it's going to be the integral of u cubed du, and we're ready to switch them out. Now, be careful on this. What am I plugging my u into? Sine x. So you're going to have to do a little bit of trig on that. So I'm going to actually set these up. New endpoints. Okay, if my b was pi halves, then my u is the sine of pi halves. Pi halves is your thumb. Everybody's on bottom. That makes it a 1. That's my new upper bound. Okay, the a in my integral was a 0. So my u is going to be the sine of 0, which is 0. Okay? And then I can switch those endpoints out so I never have to go back to the sine x stuff. Okay, then what's the antiderivative of u to the 3? 1/4 u to the 4th. Very good. Then I would plug in capital F of 1, capital F of 0. Plug in 1, you get a 4th of 1 to the 4th, which is just a 4th. Plug in 0, you get 0. Subtract, you get a 4th. Good? Okay, instead of making you do the last one, we have about 20 minutes. I want to get to some of your homework problems. So, just like we did on Monday and Tuesday, I'm going to give you a couple easy ones to try. Okay, and I got you some sweet tarts. Okay, so I want you to do, ready? Number 1, 5, and 7. 157 off the front. Okay, you guys can work together. Okay, also remember that you know how to do these antiderivatives in a calculator. So you can check literally all your work on these as you're doing your homework. Okay, 157.
Oh yeah, Miss Jordan.
Okay, yeah.
So on number 3, like the one that we did, so the new endpoints are from 2 to 1.
Yep.
Do we have to do anything about that?
No, just keep them in order and subtract and it'll work itself out.
Oh.
You're right that the endpoints did come out backwards on that one, but as long as you do stuff in the right, like keep the top number on top, bottom number on bottom, it works itself out.
Oh, alright.
That is a good question.
Thank you.
Oh, I think I left this return for my car.
No.
Yep, they're in the car. But I'll just give you, let me just do it. Most of my cookies are in the Chrome today. Okay, I'm sorry I left your sweet tarts in the car, but I'll give you what I do have. But you're working for knowledge, not for treats, right? So lots of candy canes.
Aren't they like
Good. You have to do these substitutions. Okay, but on number 4. What I would think about, the only one you don't need it on actually is number 3. And the reason why is if you took the derivative of cosine theta,
like
then you would be then you don't need this. Versus like that, you just need a chain rule. Yeah, because it's a negative 2x, you would have had to times by negative 2. If it would need chain rule, it will use. Okay, Scott, I need some more patience from you today. You've literally not taken a single page of notes. Not ideal for me as your AP calculus teacher. If you want a little candy.
Oh boy.
No. You are bringing joy to your family, that's true. That your mother is not. You want candy? You want one? Diego. Diego brings honor to his family. He's been working hard every day. You bring honor to all your family and the VC kids that have come in and not ever taken notes one way their whole life.
How about fingers?
You bring honor to your family.
I bring honor?
You've really making a change. I can't even call you a scrub anymore. Your mom might be proud. Yep. I mean, we're down to like shampoo.
Why did they go straight?
Because I don't know.
They needed spirit. Why did the mouse sleep under the oil can?
Why did the mouse what?
Sleep under the oil can.
I don't know why.
So he wouldn't sleep in the morning.
That was cute. Do the short version. Do you want the other half of that one? Like right down. You want one, Molly? You want one? Wow.
Do you want to hear
Okay, first of all, candy canes never expire.
information, call it text, 1, 2, 3, 5, 8, 1.
No, you fixed the right thing. So now rewrite it, so it'll be integral x squared.
Oh, okay.
And then you'll have your use
Top of
function.
line, it says 8, 1.
And then when you take the dx out, you're plugging in d of the 3x squared, and then those x squared. Exactly. And so that if you'll take your 3 to the front, it'll be a 1.
Solar.
What?
Sounds like
Okay. Do you want one? Which one?
exactly.
Just stole the head.
Hey, look
Try
at
the body.
you. And then you said no, you didn't want one. Is that right?
Well, it's just survive the farm.
Yes, yes. Yes.
Oh, I just stepped on my laptop. Good job. Cool. Very nice.
Check if the screen still works, and that sort of scares me. Oh, yeah.
If I open one during Avid, okay.
Take Ryan's quiz again. I mean, the second quiz. Second.
Yeah, I ate the whole 8.
Okay, Grant, you're done?
This ranch really good.
Huh? I mean, how else did you do it? You just imagined the graph and calculated the area in your
I
mind.
just like cubed the equation and then multiplied by x and then I did it.
You dweeb, what did you get?
0.
You really did that? Did you use like the Pascal triangle thing? Or you memorized the cubic expansion?
I solved it.
But how did you cubed? You like times it out 3 times?
Yeah.
And why? That's so much longer. That is not easier.
Took me like 2 minutes.
Oh, no, it could have taken you like 40 seconds.
I mean, if it's easier.
No, don't encourage this, Kevin. I want you on my side.
I was done before anyone else was done.
Nobody else was doing anything, bro.
False. A lot of people were.
Oh, well, I wasn't doing anything.
Back to being a scrub. I almost took it back.
No, I'm working on something else for another.
No, I don't. Yes?
I have a test. I have an econ test.
Okay, no, I want you to
I think I might have gotten one, so I don't remember on what account I did the original.
LOL. What is this for? What does it mean?
So when I got
You
to
guys
here,
are-
I would just say, remember that's one of your functions. Whenever those match, you can just say.
I chose that because I'm sort of tired.
Pascal's triangle's like the binomial expansion formula.
Shit.
Didn't you learn that in?
Yeah, I'm like,
Yeah, so it's, see, this is a common thread for you. It's like where it's like 1, then 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then what you do is, so this is like A, this is A plus B, and then if you square it, then it's 1A squared plus 2AB plus 1B squared. And then if you did A plus B cubed,
I remember learning it, but I never did.
then it would be A cubed plus 3A squared B. Then this would be AB squared, and then that would be B cubed.
but I don't even like a triangle.
Okay, well, you are a dweeb in my mind is all I can say. The fact that you're like, I expanded the trinomial power property in my mind and then integrated it.
They just wanted to do a shame.
I feel like probably in my mind you did it wrong and you just don't know you did it wrong. Okay, what'd you get for number 1? Did you do it? Huh? 19 over what? Over 9? Is that what everybody got? Okay, great. Then I'm not going to do it. Number 5, you got 0? Yes. Okay, if you didn't get 0, I can work through these, but these were kind of easier, so I want to save most of our time for harder ones. Number 7, have we finished it yet or not yet? Okay, keep working. Okay, if you need help, ask for help. Okay, we're working. We're working.
Taking out a part full, but trying to look at
An important poll of how to do U substitution, yes?
Yeah. Sometimes.
Okay, so here, you are almost right. So when you add 1, it's U to the this was a 1. This is
Great.
turn that 3 back to a 1. You see what I'm saying? And so then it turns into a 9. And then when you subtract those, there we go. And so then if it's 1/3, that's really 1/15 times 27 or 27. Does that make sense?
But it gives you the same
You okay? Sleepy?
because this gives
Wanna go to nurse? We're gonna talk about they expired in 2016. Tried to send them to Ashton School because he had a cough and she said, I can't let that be expired 3 years ago. And I was like, first of all, cough drops never expire. And she was like, that is not true. He's my own kid. Okay, you're right.
Yeah.
Everybody knows cough drops never expire. Okay, this is cool. Listen.
I like whenever you
Trying to find the numbers.
I just got a 502.
So now is your time
502
to
here.
shine.
When I'm
We're
short.
done doing the notes. Now you're doing your own homework. This is your homework. Okay, well, so let's start that now.
Oh, for religion, I chose other, and I just typed in mild tarot.
Yes, I saw that. Okay, so make your move. Okay, y'all are doing these homework questions, yes? Yes?
But it's gay.
That should be a DUDT. PU over 2T. And then rewrite. Wow, you're the loudest sucker eater I've ever heard. That is like unbelievable. I've never even heard someone eat a sucker before. I mean, but still, how are you making these noises? Okay, do another one. Do number 8 if you got those 2. Or those 3. Okay, and then you're shaming him, but look at your paper. You haven't even done one either. Okay, so at this point, you're going to lose a point if it's for your response. Erase those at If you have T's and U's, you can't put that points on. Okay, so then cross out your 2 T's. You did. Okay, rewrite your integral. So it's the integral of U squared. And then now what you're going to do is plug them into here and change your endpoints so that you don't have to go back to this. So if that's a 1, 1 squared plus 1 is now a 2. 0 squared plus 1 is now a 1. And then now you can just do, don't forget your du there. Now you can just do the antiderivative on it. So the antiderivative of that would be 1/3 u cubed, put it in the brackets. Remember, because you add 1 to get u cubed. You may. And then put it in brackets.
What do you think?
Like this. And then you're going to put capital F of 2 and then capital F of 1. So 2 cubed would be 8/3. And then that was 1/3. And then
Yeah, I chose,
yeah. Make sense? Okay, now, if you wanted to do what we're calling the long way, then when you got to here, you would have to go back and plug this in. So it'd be T squared and then you go here. But that takes longer because you have to go back to the T stuff, T is the same as first. If you just change them, then you can just finish it with U's. You should have gotten 7/3. Okay, so that should be switching to Q. Or wait, hold on. Oh wait, hold on. Okay, hey y'all, look at number 3.
Yes.
Okay, look at number 3. That one actually doesn't even need U sub. I already scribbled all over it. Okay, but when you look at it, here's how you know if you need U sub or not. If you were taking the derivative and you need chain rule, you would need U sub. So if this is cosine theta, Does that need chain rule for you to take the derivative? No. Then you don't need u sub to do the antiderivative. What's the antiderivative of cosine? So you put sine at theta in the brackets, and then you can just plug in pi halves and 0. So this one is not u sub. And if you look right above here, it does say some of the problems require u sub, but some of them do not. Okay, it's not a myth. It's real. Okay?
It's just like global warming.
Number 7, what did we say it was? 7/3? 7/3? Okay, you can check all of these on the calculator though. Do we want to finish this? What's the sign of pi halves? 1. What's the sign of 0? 1 minus 0 is 1. Good? Okay, anything else? 4 minutes. We'll do maybe a couple more tomorrow. But get your lives together, people. Okay, you can do it. Okay, you have a quiz on Friday over U substitution. And guess what? Where will I be? Not here.